Pak WR ya. Pak WR, ya.
Petugas, Pak.
Tapi masih menyempatkan untuk hal yang sifatnya seminar ya. Baguslah.
Diundang dari Facebook itu loh, langsung disimpan.
Nah, tadi saya diminta Pak Abu untuk menyampaikan ini ya, saya share ke Facebook, ternyata banyak juga minatnya.
Masih, Prof. Kita juga ngundang untuk Neutron School ya, Prof ya.
Oke, ya. Itu nanti ya. Itu juga ya, daring juga ya, Pak ya?
Daring, full daring, Prof.
Daring, ya.
3 hari, Prof.
Iya.
22, 23, 24 ya.
Oke, ya.
Kita undang juga ke UMM ya, Pak Nur ya, Prof Nur.
Masih mute, Pak.
Oh, iya, Pak Bu. Nanti beberapa dosen yang mengikuti.
Ya, makasih Pak Nur.
Karena kemarin diundang langsung Pak Rifai ini, langsung saya sampaikan ke tim.
Ya. Ini ya, bahasa Inggris sepanjang ya?
Yes, bro.
Assalamualaikum, Mbak Rifai.
Waalaikumsalam warahmatullahi.
Oke, niki Pak Jupri dari Madura, Pak Rifai yang dulu makan bareng.
Maaf, double itu zoom-nya ini.
Niku asli tiang Solo.
Mute Pak Rifai.
Ya Pak, ini saya kira ini kan ada ini Pak Iwan di belakang gitu. saya kira ini pembawa acaranya Pak Iwan, ternyata Pak Dian.
Saya kapan-kapan nanti kalau sudah ada luring juga pengen ke BRIN ya, ke Badan, sekalian jalan-jalan.
Monggo, Prof.
Sangat senang sekali, Prof.
Kalau yang ini rencana yang pengukuran kapan, Prof? Ini ya, yang ini ya, Pak Pujono.
Saya menyesuaikan aja ya, Pak Rifai ya. Mungkin ya paling tidak mungkin bulan depan masih Pak. September, Oktober mungkin dimungkinkan mungkin.
Oh gitu. Ya. Untuk mudahnya memang setiap bulan ada 2 kali operasi gitu ininya. Nah ini yang Agustus ini pekan Jumat besok. Jumat besok naik lagi gitu kan ini. Nah kemudian nanti September awal naik lagi gitu.
Ya, mungkin September
ya.
nanti.
Intinya dua kali per bulan gitu. Nah, Pak Pujono ada juga tuh. Gimana Pak Pujono?
Pak Rifai. Assalamualaikum.
Sampelnya gimana sampelnya? Udah siap gimana?
Insya Allah minggu depan siap Pak untuk pengawasan hasilnya.
Oh gitu. Siap lah. Makin cepat makin baik.
Amin. Ya, siap.
Kehabisan bahan bakar nanti.
Ya, siap.
Mas Dian, mungkin kita mulai Mas Dian ya.
Oke. Apakah suara saya dapat terdengar?
Ya, jelas.
Oke, loud and clear.
Yes.
Good afternoon, everybody. Welcome to our webinar today, which is the 10th episode of the Voice of Research series. Today's topic is about the application of neutron scattering for non-destructive inspections. First of all, I want to introduce myself. My name is Dian Adi Prastowo. I'm a junior researcher at National Research and Innovation Agency of Indonesia, or BRIN. Here, ceremony of this webinar. Dear all participants, before we start our webinar today, I want to inform you the schedule of the order of our meeting today. First, this webinar will be opened by opening remarks from Mr. Abu Khalid Rifai as the head of Research Center for Radiation Detection and Nuclear Analysis Technology, and then from Mr. Rohadi Awaludin as the chairman of Nuclear Energy Research Organization. And then there will be 4 presenters in this webinar, followed by question and answer session after all 4 presentations are over. The lectures and the discussion will be guided by Mr. Iwan Sumirat, our researcher at National Research and Innovation Agency. To begin our webinar today, let's listen to the opening delivered by Mr. Abu Khalid Rifai, the head of Research Center for Radiation Detection and Nuclear Analysis Technology. Mr. Abu, the time is yours.
Thank you, Mr. Dian. Dear ladies and gentlemen, Chairman of Nuclear Energy Research Organization of BRIN, Dr. Rohadi Awaludin, our colleagues from UNSTO, our colleagues from abroad institutions, our colleagues from the BRIN, University and Industry in Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Greeting to all of you. Praise and gratitude we always pray to God Almighty so that we can gather at this event, Voice of Research, which in this time with the theme Symposium on Applications of Neutron Scattering for Non-Destructive Inspections. This symposium webinar is special because this is one of our events to celebrate 30 years of neutron scattering research and technology in Indonesia, with the establishment of related facilities in the Serpong nuclear area at the time. So on behalf of our research center, PRT DRAN, our research center for radiation detection and nuclear analysis technology, BRIN, National Research and Innovation Agency, I would like to express our speakers, Professor Dr. Anna Paradowska from UNSTO, Australian Nuclear Science and Technology, Professor Dr. Muhammad Nur Ilman from Gajah Mada University, Mr. Muhammad Rifai Musli, and Mr. Fakhrul Raji Akbar from National Research and Innovation Agency, for your time to share your expertise and experience in this field, and also thanks to all of you for the presence in this event. Ladies and gentlemen, 30 years ago, 20 August 1982, the President of Republik Indonesia, Soeharto, inaugurates the facility, so-called neutron spectrometry installation at Nuclear Serpong area, which is the largest facility in Southeast Asia. Since the time Indonesia come to the world-class neutron beam research related to the facility, which is consists of 7 facility of neutron scattering and 1 for NEA. So the facilities is residual stress diffractometer, neutron texture diffractometer, triple axis spectrometer, neutron radiography and tomography, small angle neutron scattering spectroscopy, high resolution small angle neutron spectroscopy, high resolution powder diffractometer, and neutron activation analysis. So as we know that non-destructive inspection is one of the methods that very important in various fields, such as industrial, archaeology, and also cultural heritage. So in this time, we will together learn the powerful of neutron scattering method for non-destructive inspection. That will be presented by our distinguished speakers and will be discussed together. So in general, we hope this momentum can be used to continuous improvement of research and technology of neutron scattering in Indonesia with national and internationally strong collaborations. finally, we would like to invite our chairman of Nuclear Energy Research Organization BRIN, Dr. Rohadi Awaludin, to give remarks and open the symposium webinar. Thank you and best regard to all of you.
Thank you, Mr. Abu, for the remarks. The next is some opening remarks from Mr. Rohadi Awaludin, the chairman of Nuclear Energy Research Organization. Mr. Rohadi, how are you?
Okay, thank you, Pak Dian. Can you hear my voice?
Loud and clear.
Okay. Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Our distinguished speakers, our distinguished guests, and our participants of this webinar. First of all, I would like to welcome our distinguished speakers, our distinguished guests, and participants today. Thank you very much, Prof. Anna Paradoska from ANSTO for your time today, joining our webinar today. I believe that you I would like to thank you, Prof. Muhammad Nur Ilman from Gajah Mada University. Terima kasih, Prof. Ilman, atas kehadirannya for joining us today. I believe that your lecture, your expertise will be very valuable for our participants today. And thank you also, Pak Rifai Musli, Pak Iwan Sumirat, and Pak Faruk Rozi. I believe that your experience is very interesting and very useful for all of our participants today. And also thank you for all participants today and of your presence in this webinar. I believe that our event today will be very important for us in development and also application of Neutron BRIN in Indonesia. Reactor in Indonesia, 30 megawatt reactor. It is a multi-purposes research reactors, and one of the most important facility is neutron beam facility. It can be used in many applications, and including non-destructive inspection, what we will discuss today. And hopefully the application can be developed intensively, and many knowledge and technology can be developed using the neutron facility. And also the important aspect in the technology development is the human resources. Therefore, it is expected that along with the various activities and research and development of a neutron beam, human resources can also be developed simultaneously at the same time with the activity of research and development. So it is expected that in the and we hope that after revitalization of our research reactor, we have a plan in revitalization of our research reactors, and then we can also revitalize our infrastructure related to neutron beam utilization, research and development. Ladies and gentlemen, last but not least, I would like to thank the organizing committee of this activity, this symposium or webinar. Thank you again to our speakers, Prof. Anna Paradovska, Prof. Muhammad Nur Ilman, Pak Rifai, Pak Iwan, and Pak Faruk Rozi. I'm very sure that this event will be very beneficial for all us today. And I declare that the webinar is officially open. Thank you very much. Thank you, Pak Dian. You are still mute.
Yes, okay. Thank you, Mr. Hadi, for the remarks. Now, we go to the main event of this webinar, which are the presentations and lectures that will be delivered by our speakers today. The first speaker is Mrs. Anna Paradovska from Australian Nuclear Science and Technology Organization, or ANSTO. The next is from Mr. Muhammad Nurilman from Universitas Gadjah Mada, Indonesia. And then from Mr. Muhammad Rifai Muslih and Mr. Fahurazi Akbar. Both are our researchers at National Research and Innovation Agency. The lectures and the discussion will be guided by Mr. Iwan Sumirat as one of our researchers at National Research and Innovation Agency. Mr. Iwan, are you ready?
Okay, I'm ready.
Okay,
Thank
loud
you.
and clear. The time is yours.
Okay, thank you very much, Mr. Dian, for your opening. And good evening, Mr. Rohadi, Dr. Awaluddin Rohadi, as the chairman of RTN, Dr. Abu as the head of RTDRAN, distinguished and excellent speakers, Professor Anna Paradowska from ANSTO, Prof. Nur Ilman from University of Gadjah Mada, Mr. Rifai and Mr. Oji from BRIN. So as mentioned by the MC, that we have 4 distinguished and excellent presenters today. So it's our opportunity to learn, to hear, and to discuss with such excellent experts in their field. And before I start the first presentations from Professor Anna Paradowska, let me show the information about the speaker. So the first speaker is, can you see my screen now? Okay, thank you. Professor Anna Paradowska, I think neutron scattering persons will know her very much. Yeah. So she is co-joint professors in advanced structures, materials, and industrial engagement manager at the ACNS at ANSTO, Australia. She got a PhD in mechanical engineering from Monash University in 2008 and got her degree in material science and master degree in material science engineering from Wrocław University of Technology, Poland in 2001. And Professor Anna specialized in residual stress analysis using neutron and synchrotron diffractions with a particular focus on welds and advanced manufacturing processes. And I think the primary goal of Professor Anna research is to relate residual stress, mechanical and metallurgical properties to manufacturing procedures and integrity requirements of engineering component. And before present positions, Professor Anna was working as instrument scientist on the neutron strength scanner engine X at ISIS and Rutherford Appleton Laboratory, United Kingdom, and also at Kowari Instrument at ANSTO. And she has a very excellent record on securing funding to access large-scale facilities in both Australia and around the world. And I think for her scientific achievement, Professor Anna has published 1 book, 2 book chapters, and over 150 papers in scientific journals and also in conference proceedings. And also she has won several grants for his activity in her research. And there is one important and I think interesting for us that Professor Anna has passionate about building bridges between science and industry. And this passion also in line with neutron scattering facility here. But I think we have still many things to learn and to do. And through Professor Anna's presentations today, I am sure that we will have many learn and many things to copy and imitate the success of ANSTO through Professor Anna's activities. So without further ado, I will welcome Professor Anna to give her presentations, and you have 20 minutes, and then we will discuss after all presenter has finished their presentations. Please, time and screen are yours, Prof. Anna.
Thank you very much for this kind introduction. Do you see my screen?
Yes.
In the presenter mode, yes?
Yes, we do.
Excellent. Thank you very much for inviting me. Salam alaikum, everyone. And today I will be talking about Neutron for industry and our experience at ANSTO on building these bridges between academia, large-scale infrastructure, like our neutron scattering facility, and universities. Okay, I'm just going to start my timing. Okay, so for those one who never been to Australia, you can see this beautiful hut in the bush. That's our ANSTO facility, and we here have a HIFA reactor, which is the old reactor. I did my PhD on it, but 11 years ago we built a new reactor, Opal, an open pool reactor, and our neutron scattering center for Australian stress engineering is located over there, and we have multiple instruments that providing access to our academic and industry users. We are located 30 kilometers from the Sydney CBD, 800 kilometers from Melbourne, and only 20 minutes from the beach. I would strongly recommend it for you to come and visit us. So we are 20 megawatt open pool reactor. We also have other facilities around ANSTO that provide the services to Australia, environment, nuclear fuel cycles facility. We have an environmental engineering mining institute. We also currently building a Synrock plant to commercialize one of our businesses. We have a really a large interest in utilizing our large-scale facilities in Opal multipurpose reactor, Australian Centre for Neutron Scattering, as well as Australian synchrotron and Center for Accelerators, which ANSTO is managing, to provide a contribution to Australian national priorities, especially in advanced manufacturing, transport, energy resources, soil and environment change and health. And I think all globally they are important global challenges that we all have to target. So I think in my work as a industry engagement manager at the Australian Centre for Neutron Scattering, I have to help industry access our facility. You know, the biggest challenge for us is also explaining to them that we are not for only early discoveries. We are doing that too, but we also can help across the value chain for the industry. So in early stages, prototyping and production across many industries. So ANSTO normally for Australian industry and general public is known for nuclear medicine production, but we are at our neutron scattering facility, we providing access and support to pharmaceutical industry, biotechnological industry, advanced manufacturing, food and agriculture, mining, and defense. So we are helping in the discovery stage, as well as optimization of process improvements to structure integrity and improvements in manufacturing and production. Across many differences. This is currently our portfolio of customers, and you can see Australian and international companies comes and visiting us and utilizing multiple beamlines, and the research across our facility is from food science, chemical engineering, and probably because my background is in welding and advanced manufacturing, most of our clients are actually in welding and structural integrity of the components. But it is been a learning experience, not only for me, but for the whole our team, that industry does not pay for experiment. They are paying for measurements that can help them optimize their performance. So as nobody is searching on the internet, on eBay or Amazon's, where to buy neutrons, we have to think of the way how we can sell our products to our potential customers in a way they understand they need us. So I am not selling neutrons, I'm selling characterization and process performance, process development, materials consulting, new materials development and optimization, and I am supporting industry in structural analysis and assessment. So I am trying to speak the same language that the industry that needs our services can understand and relate to it. I think it is the biggest learning that I have since I started this job, that we need to understand that our clients need a full solution. So I'm an expert in strain scanning. So I work on the instrument called Covari strain scanner. And the biggest advantage for our instrument is non-destructive. It provides a deep penetration, full trajectory states. You have one of those instruments yourself. For me to be able to provide a solution for the industry, I have to combine my expertise with my colleagues around the ANSTO and who are doing the finite element modeling and X-ray and contour method. So together we're providing like a package, yeah. So we can support the industry with portable technique and non-portable technique and validate large complex structures. And you can see on these pictures we have a 3D additive manufacturing components, and we also have a large-scale pipeline. It's a 1 meter diameter and 1 meter length that came from TWI to measure residual stresses in the full-scale component. This is probably still the largest component ever measured on the strain scanner around the world. So why are we interested in the residual stresses? Because of the fracture, stress corrosion, cracking, fatigue, and distortion. And all those are critical for performance, and they are really important for the industry that I'm working with. So I would like to highlight a couple of projects that I've been involved with and that may trigger some ideas for you to help you develop collaboration with the Indonesian industry and academia. So for example, here we have measurements of residual stresses in the gas pipeline. So this is large scale manufacturing. This hot tub, they like to call this, is around 700 kilogram weldment, yeah. And so what we did there, we helped them optimize. We helped multiple clients who are part of the energy pipeline CRC, which is a corporate research company, to help them change current state of knowledge about the welding procedure in this state. So we, instead of asking them to give us samples that we wanted to measure, we asked them how can we become a part of their R&D team and how we can combine forces to solve this problem. So, and we did the measurements, the microstructure characterizations, as well as the modeling to simulate how optimization of the welding procedure can help in this particular, solve this problem. And for one client, we may be expensive, but for multiple clients, when they have a similar problems in the industry, the cost can be shared between them and can be beneficial for the whole pipeline industry. So I think I am really keen on large-scale collaboration with government funding organization like the CRCs, because it really helps share the cost for the industry. Another important thing is to actually collaborate with other large-scale infrastructure to help develop confidence that when we measuring the residual stresses in Europe or in USA or in Indonesia, we still have the same measurements, and the measurements are reliable and useful. So here is one of our PhD students from Manchester, Pierre, and he was having an in situ system to measure residual stresses in nickel-based superalloy disk. And we were able to measure them in multiple locations and convince the founding partner, which was a Rolls-Royce, that we are able to measure these things reliably, and we can optimize the heat treatment of this process because we can see measurements change in stress relaxations when it's happening. So in this case, the relaxation occurs across 8 hours, and we can simulate not before and after, but when it's happening. I think there is a lots of interest for the industry to understand change in the material processing in situ. And I think I will be particularly characterizing, trying to point it out, those opportunities for you. And I'm in a civil engineering department at the University of Sydney, and I developed several collaborations in columnar structures and bridges and T-joints. So there is a lots of opportunities for us, especially that the civil engineering industry is looking for green steels. Green steels means high strength steels, thin walls, and there is a opportunity that we can provide the residual stress characterization in these joints and help them establish current codes and standards, improve the standards, make them introduce novel technique, welding technique into the quite a conservative civil engineering industry. So I think in this case, we have done several residual stress measurements with our academic PhD students, and then we can translate that academic experimental study to the industry and help them develop novel welding technology for civil and structural engineering applications. I am particularly interested in civil engineering because I'm interested in 3D printing, and we have an opportunity to move to much more complex, much more efficient design in connections in civil applications. And we have a University of Sydney Manufacturing Hub, and I am currently developing the Australian Stress Engineering Center for Australian industry, with particular focus for additive manufacturing. I really believe that combining modern manufacturing techniques with artificial intelligence and machine learning and additive manufacturing can give us opportunity to create not only beautiful structures, but also a very more efficient way and greener buildings and more efficient designs. So in my current years, I am strongly focusing on building setups that are particularly fit to study things in situ. And I already showcased the in situ heat treatment, but I'm also working on a system. We build a system to measure residual stresses during the manufacturing 3D printing of VAM. So it's weld arc additive manufacturing. So this system here, we with our team built on the budget, but is a very quick proof of concept for the industry that we can study strain evolution. We can study on imaging beamline defects formations and distortion during manufacturing. And I think that creates an opportunity for the industry to look to add value to the current knowledge, but also to see us as a partner R&D in their future projects. Another project that we've been recently able to develop is a laser metal deposition system. So first system for the purpose built for the Neutron strain scanner, but we also have a plan to put it on our imaging beamline Dingo instrument to stimulate cladding and 3D printing and study these processes as they're happening. I mean, some of those processes for the was done also at ILL, but they did not use a powder. Powder is very difficult to deal in the reactor sources, but I think because of contaminations, but we were able to convince our regulators and our leaders that this is the area that we should be strategically investing, because that's what our industry wants. They wanted to study manufacturing processes during manufacturing. Okay, now I would like to move to Dingo. I know you also have an imaging beamline, and you understand the concept of imaging. But I think the biggest things I wanted to showcase is how to present neutron imaging to the industry. So you always have to relate to something what they know. So this is why I'm using these images very often when I'm talking about the neutron and X-ray imaging, because everybody knows X-ray. X-ray imaging that we use it when we have a broken bones or something like that. But neutrons adds value in a way that we can see polymeric structures, we can see hydrogen in the materials, and I think this particularly highlights that combinations of the technique is very valuable for the industry. I'm sorry, I'm just going to go through this one. And I think we are now looking into much more complex shapes components. And here we have an additive manufacturing tomography driven experiment. So I'm using three-dimensional image from Dingo to actually start to do strain scanning. So we can see in this material, this is a part of the complex component that have a supportive structure inside the 3D printed component. Without of the imaging, full-scale imaging, it would be really very difficult to locate gauge volume fully emerged in a subsurface. But with because we dealing here with lots of holes and shallow structures, it is important not to just have a laser scanning of the components. You need to have internal features, and I think only neutron imaging is capable to provide that on thick, large-scale components. So we advising our clients who do very complex 3D printings on porosity distribution, dimensional stability, if there is any defects. And in this particular one, you can see this red feature that occurring there. So this red feature is actually organic material captured in a supporting structures. So normally you will not be able to. This is my last slide.
Okay, thank you. Sorry, I would like to remind you, you have more 3 minutes left.
Thank you so much.
Thank you.
So I'm just gonna quickly come back here that this supporting structures it grabs the impurities from the EDM cutting off into the pores of the supporting structures and change the balance of this thing. So we were able to identify a problem that they have it in their processes, and by introducing ultrasonic cleaning, you can remove this from your structure. But what showcased nicely that we can see aluminium very clearly here, and we can see organic dirt. Yeah, and knowing this knowing this problem in manufacturing, it is very relatively easy to help our client to optimize the additive manufacturing. We do lots of work in composite materials, also in concrete structures and turbine blades. There is a lot of opportunity for imaging. There is an interest, and I think we will be strongly developing this technology, rapid imaging, as well as radiography for an in situ monitoring of additive manufacturing processes in the future to make sure we're ready for industry challenges. So I just wanted to summarize that I strongly believe that we provide opportunity to make structures more economical, reliable, and safe via neutron scattering. And it is very difficult to work at large-scale facility and convince industry to work with you, but it's worth it doing because it's very rewarding, and we were able to help many industries in the past to optimize their products, optimize the processes, and also highlight their technology that actually leads to sales. So, for example, if they develop a product, we can help them working with large-scale government facility, gives them credentials and opportunities to market their product. So I am finding working with industry very rewarding, and will say that especially for young people in the audience, career with the industry and academia is a future. Because more of the new instruments will come online, and that technology is, that technology will be more open into application for the industry. And I believe that your facilities is well equipped to provide a direct response to Indonesian industry. And if there is any challenges that our facility could help, we are here for you, and we wanted to work with you in the future. Thank you very much.
Okay, thank you very much, Prof. Anna, for your very excellent and interesting presentation. So we would very happy if you still stay with us because I'm sure that there will be questions and discussions we can do until all presentations have been done. So let me move to the next presentations that will be held by Professor Nur Ilman. Before Professor Ilman give his presentations, let me show his informations. So, I think you have seen my screen. And this is the general CV of Professor Nur Ilman. He is currently a professor of mechanical and industrial engineering at University of Gadjah Mada, and he has bachelor degree from the mechanical engineering of UGM, and master and PhD degree from Leeds University on physical metallurgy. And we have shown here that Professor Ilman, very active and productive lecturers and researchers. So many grants he has achieved, for example, for current, and several years ago, we have 18 grants that Mr. Ilman has received. And also for his scientific achievement, within 5 years, Mr. or Professor Ilman has published many distinguished papers in very well-respected journal. So within 5 years, Professor Ilman has published around 17 reports, so very productive. So before Professor Ilman give his presentation, let me stop my shares. Professor Ilman, are you ready to give your presentations?
Yes.
Okay,
Yes,
please, time and screen are yours.
thanks.
You have 20 minutes and 3 minutes before, and I will remind you. Thank you.
Thanks. Actually, everybody else can see my presentation, my slide.
Yes, yes, we can.
Okay, right. Good afternoon, ladies and gentlemen. First of all, I would like to thanks to organizing committee for inviting me to be presenter here. And I apologize for my English because it's not very good. I hope you understand what I'm talking. This afternoon, I would like to talk about my research area, which is building residual stress. And I'm not focusing on how to measure residual stress using neutron diffraction, but I want to focus on the relationship between residual stress and mechanical properties of wet matter. I think everybody knows that residual stress is defined as stress that would exist in a material or a structure after all external loads are removed. We can see from these pictures. And why we study residual stress? Because residual stress can cause deleterious effects such as brittle fractures, fatigue, and stress corrosion cracking. And if we move on to next page, and these are examples of failure caused by depression of residual stress in belt joint, like brittle cleavage fracture, and then due to the residual stress, the fatigue life is reduced, and also residual stress promotes stress corrosion cracking. If we look at residual stress here, we can see that residual stress can be divided into 3 groups based on the cause of residual stress. First, residual stress can be created by materials such as multi-phase material inclusion, and also can be resulted from material processing, especially joining, welding, and brazing, and also material loads such as rolling and thermal temperature feed, and also hydrogen diffusion. And this is a diagram show the relationship between thermophysical, metallurgical, and also mechanical properties. We can see that the welding need heat here, and then heat cause temperature distribution here, and then due to the difference in temperature distribution, it can produce residual stress and also welding distortion. On the other hand, the metallurgical factor play important role in affecting the final microstructure. You can see that metallurgical factors such as chemical composition and austenite grain size can affect transformation behavior, which can be seen from phase diagram and continuous cooling transformation. And on the other hand, that the heat input can influence cooling rate, so combined effect between cooling rate and metallurgical factor, and produce the final microstructure. And then this final microstructure can influence the strength, fatigue, and toughness. So my research area especially related to residual stress and its effects to fatigue here. And then we have been developing some distortion and residual stress mitigation technique, and we can see to the next page. The fact that welding cause local heating, so that it can produce this temperature distribution, which is in the wet metal and area near the wet metal has a high temperature, but on the region away from wet, the temperature is relatively similar to the ambient temperature. And then from here we can approach using a classical Rosenthal equation, which can be which represent the distribution of temperature and also welding thermal cycle, something like this. And this is the mechanism of residual stress formation that actually due to local heating, it produces residual stress where in the wet metal and region near the wet metal reveal tensile residual stress, and to compensate this, the region away from the wet produce compressive residual stress. And you can see that residual stresses can be divided into two, which are longitudinal residual stress and transverse residual stress. And this longitudinal stress can be represented by this equation. And actually, the residual stress can affect fatigue behavior of the wet. This is because by using superposition approach, that the total stress when applied stress work in the structure equal to residual stress plus applied stress. So it means that when the residual stress is tensile, it magnifies the total stress. But if the residual stress is compressive, it reduces the total stress. So in this case, that tensile residual stress is more dangerous compared to compressive residual stress. And I think this is an example of experiment to measure, to study how the crack growth under dynamic loads. And this is the main focus of our research. And normally, the fatigue crack growth rates behavior of material can be studied using this DEDN as a function of stress intensity factor range, delta K. And from this diagram, we can see three different regions, which are crack initiation here, and then stable crack growth, which follow Paris law, and then the final final fracture here in the state 3. And then we focus on the Paris region. From here we will get fatigue crack growth rate, which is DEDN, and then we can get Paris constant, which are C and N here. And then this factor can be, this C and N values can be influenced by many factors, as well as like temperature or environment, and then processing, post-wet heat treatment, and so on. So this is my research. We have been done some of this work. Actually, stress living can be divided into two, which are thermal treatment and mechanical treatment. And this treatment can be performed during welding, or we can say in situ welding, or in process treatment, and after welding, which is called post-weld treatment. So in thermal treatment, there are many various residual stress mitigation techniques, such as STT, static thermal tensioning, and then transient thermal tensioning, low stress modulation, and heat sink. While post-weld treatment consists of post-weld heat treatment and flame heating. And similarly, for mechanical treatment, we know about in-process treatment, which consists of mechanical tensioning, vibration assisted welding, roller tensioning technique. And for post-weld treatment, we know mechanical stretching, vibration stress relieving, softening, and so on. So the advantages or the disadvantages between the two technique are that thermal tensioning is more efficient than mechanical tensioning, because tensile stress can be easily generated by increasing temperature, whereas mechanical treatment require heavy equipment for producing such large force. However, there is a disadvantage for however, mechanical tensioning has advantage, which is clean and environmentally friendly, because it does not produce pollution. So I would like to show you some result of my research, which are collaboration between my university, UGM, Gajah Mada University, and Badan or BRIN. First, we developed STT treatments where this treatment is performed by locating two static heaters at both sides of the web along the plate length. This is the plate length, and at the same time, in the weld region beneath the web is cooled by cooling system, which consists of water flow. And we, after welding, we measure the longitudinal residual stress. We can see that in as welded condition, it shows high tensile residual stress, especially in wet and heat affected zone. But using STT treatment, it's reduce the residual stress, especially in weld region, and to become compressive residual stress. And then we also study the fatigue crack behavior. In fact, that the weld under STT treatment show better fatigue crack growth resistance compared to that of as welded condition. This is, we call it in situ, in process treatment, because the treatment is conducted during welding, so it saves time. And then this is the mechanism of how STT can minimize welding residual stress. Actually, the introduction of log heating here, it produces we call it thermal tensioning, and thermal tensioning is opposed to the shrinkage stress caused by wet. So the resultant of the stress load will minimize each other. And then next, we develop transient thermal transitioning (TTT) treatment, and we located two heater symmetrically, and just move together with heat source tool or torch, and again we measure residual stress. It shows that the TTT treatment is proved to be better method to reduce residual stress. And we can see also the fatigue crack rate. You can see that the TTT treatment effectively reduce fatigue crack growth rate. And then we also started the heat sink by locating this cooling jet using nitrogen liquid. We quench here. This is so the reason is to generate thermal gradient. So in this case, it produced tensile tensioning. The principle is the same as static thermal tensioning. So in here, the residual stress can be reduced. And then we try to combine TTT, which is heater here, and TAC, trailing active cooling here, and then it results something like this. So we say that this is hybrid TAC and TTT. And here we found that this method is more effective compared to the individual TTT or TAC. We can see that the significant reduce in fatigue crack growth rate in metal region. And then this is the mechanism of the how residual stress is reduced, and we propose based on the previous reports from some journals. And then this is we move to mechanical treatment, which is the mechanical tensioning. This is the basic principle of mechanical stretching. I think everyone knows about this. I think I should move to the next page. And we try to use mechanical vibration for improving mechanical properties, especially strength and fatigue, and reduce residual stress. Here we use
Prof. Filman, you have 3 minutes left. Thank you.
Yeah, I think this local vibration assisted welding, where welding is performed, where vibration is applied to welding process, and we can see that the use of vibration during welding show reduce the residual stress here, and accompanied by better fatigue crack growth performance. And the final my presentation. This is some papers that have been resulted during collaboration between my university and Badan. I think that's all. Thanks.
Okay, thank you very much, Professor Nur Ilman, for your presentations. Very interesting topics, I'm sure, because it's related the mechanical properties, especially residual stress, to the safety of the materials. So please stay with us. I'm sure the audience have many questions to you, and we will be have a discussion in the end of the sessions. So thank you again from to Prof. Nur Ilman. And let me move to the next presentations that will be held by Mr. Rifai. So I'm going to show you about his informations. So please, could you stop shares, Prof. Ilman? Okay, thank you. So let me Mr. Rifai. Sorry. So Mr. Rifai has been with us in Neutron Scattering Laboratory since 92, I guess. So he has a background in electrical engineering for his bachelor degree, and he just finished his master degree in metallurgy and material from University of Indonesia. So we can see that he has been joined Badan since 1992, and he has been very long and deep understanding of one of our instruments we called Neutron diffractometer for residual stress measurements. So he has been involved in many trainings and fellowships. Almost all of them held abroad in Japan, Australia, Europe, including Russia and Germany, and also France. And although he didn't send the information about the scientific achievement, but to my knowledge, Mr. Rifai has been published many respected papers in respected journals. So I think we will hear about his research now. And please, Mr. Rifai, time and screen are yours.
Okay, thank you very much for time. Share my screen. Can you see my screen?
Okay, I can see.
Screenshot mode slideshow. Okay, thank you very much, and good afternoon, ladies and gentlemen. Since yesterday it's our Independence Day, I will express my presentation in bahasa Indonesia. Sorry for Professor Anna, but I think you can guess what I'm talking about. Yeah, in this time, I will introduce myself not as instrument scientist, but I'm a researcher. So, pada kali ini saya akan memperkenalkan teknik difraksi neutron dan sinar X. Kali ini sengaja saya ini kan sinar X juga gitu ininya untuk pengujian tegangan sisa tanpa merusak. Pada backgroundnya kita bisa lihat ini gedung gate hall yang saya ambil beberapa waktu yang lalu, di mana plate batan sudah tidak ada lagi di sini. Pokok bahasanya adalah tentang pendahuluan, mungkin akan beberapa saya skip karena sudah diterangkan oleh Prof. Ilman seperti itu. Kemudian pengukuran tegangan sisa dengan teknik difraksi, aplikasi di bidang rekayasa industri, dan kita tutup. Nah, kemudian di pendahuluannya untuk difraksi itu ada dua sumber yang bisa kita pakai, yaitu X-ray, laboratori X-ray, ataupun dengan menggunakan neutron yang dihasilkan oleh reaktor kita. Reaktor kita itu dibangun sekitar tahun 86. Ini saya belum lahir di Batam seperti itu, oleh Jerman. Nah, kalau untuk yang X-ray sendiri bentuknya cukup kecil begitu, ininya 2 inch kali 10 inch tipikalnya ininya. Nah, dia akan menghasilkan sinar X dengan perpindahan elektron seperti itu. Sementara untuk yang reaktor, di reaktor kita itu terjadi proses fisi ya, pembelahan uranium-235. Saya kira ini hal yang sudah familiar untuk teman-teman yang di Batan. Nah, kemudian di reaktor sendiri begitu kan ininya, sebenarnya reaktor itu gitu kan ininya itu inti reaktor atau core-nya itu cukup kecil begitu ya, ininya kurang dari 1 meter kubik gitu ininya. Ukurannya kira-kira 60 kali 60 kali 60 cm kubik seperti itu gitu. Tapi untuk mengungkung itu semua diperlukan fasilitas yang begitu besarnya, luar biasa begitu, karena memang kita menghandle sesuatu yang dalam tanda petik berbahaya seperti itu ini ya, meskipun nggak perlu kita khawatirkan. Nah, seperti itu. Nah, kemudian untuk tegangan sisa sendiri saya kira tadi sudah diinikan oleh Prof. Ilman, sehingga yang ini akan saya skip saja seperti itu. Nah, untuk pengukuran tegangan sisanya sendiri seperti itu gitu kan. Ini ada beberapa macam teknik yang bisa kita gunakan seperti itu gitu kan. Ininya ada misalnya X-ray begitu kan. Ininya ini kelompok yang non destruktif, kemudian semi destruktif dan destruktif. Yang untuk yang difraksi seperti itu menduduki di kelompok yang ini, yaitu non destruktif. Nah, kemudian X-ray sendiri ada X-ray dari tabung yang tadi saya ini kan perlihatkan, atau juga bisa berasal dari X-ray sinkrotron. Sayangnya sinkrotron ini sampai sekarang kita belum punya. Semoga sih gitu kan ini di masa mendatang kita punya sinkrotron sehingga kita bisa lebih lengkap lagi evaluasi tegangan sisanya. Nah, kemudian kita juga di sini mempunyai neutron. Untuk yang ultrasound dan magnetik tidak akan saya inikan di sini seperti itu. Nah, kemudian dengan menggunakan neutron kita bisa mengukur sampai ke kedalaman beberapa senti begitu ininya tanpa merusak. Nah, kemudian begitu kan ininya, karena kita menggunakan neutron tentunya begitu kan ininya sumbernya cukup terbatas begitu ininya, karena apa, di Indonesia sendiri kita hanya ada 1 reaktor yang besar begitu di Serpong, sehingga peralatan difraksi neutron, difraktometer neutron untuk pengukuran sisa itu kita hanya ada di Serpong sini seperti itu ininya, sehingga apa, dari sisi harga kita sudah tahu bahwa neutron itu sangat mahal begitu kan ini yang tadi sudah dikemukakan juga oleh Prof. Ana seperti itu. Untuk mengurangi harga mereka harus berkolaborasi satu dengan yang lain seperti itu ininya. Nah, kemudian sedikit kan ininya sumber-sumber yang bisa kita gunakan seperti itu gitu ininya. Nah, kemudian ini adalah pengukuran tegangan sisa dengan menggunakan teknik difraksi seperti kita tahu begitu kan ininya, kalau sebuah material begitu kan ininya dikenai tegangan begitu, maka material atau kristal di material tersebut itu akan mengalami perubahan jarak kisi seperti itu gitu. Nah, dengan menggunakan teknik difraksi begitu kan ininya, kisi-kisi dari kristal itu akan dengan mudah diukur seperti itu ininya, sehingga dengan menggunakan teknik difraksi maka kita bisa tahu bahwa benda tersebut itu mengalami stres atau tidak. Di sini ada 2 macam stres, ada applied stress, ada residual stress. Nah, kemudian di tempat kita begitu kan, alhamdulillah begitu kan ininya dari teknik difraksi itu kita cukup lengkap begitu, dari mulai neutron begitu kan ininya, kemudian portable X-ray begitu, ini laboratory X-ray ataupun yang mobile X-ray, kita ada ketiga-tiganya alhamdulillah seperti itu ininya. Nah, kemudian ini adalah difraktometer neutron yang ada di tempat kita. Ini tahun 90-an, saya belum lahir waktu difraktometer ini diinstal untuk pertama kali. ininya. Tapi kemudian saya bergabung dengan PPSM waktu itu, begitu kan? Ininya tahun 92, begitu. Ini kondisinya seperti ini kira-kira, seperti itu. Pada saat itu peralatan ini adalah powder diffractometer. Kemudian karena ada penambahan alat di PPSM waktu itu, peralatan ini kemudian diubah menjadi residual stress diffractometer, seperti itu. Bisa kita lihat di sini bagian sini gitu ya, ininya karena ini powder diffractometer di sini kosong sama sekali, begitu kan? Ini ya tidak ada aparatus tambahan seperti itu gitu kan ininya. Nah, pada saat ini begitu kan ininya itu shutter dari peralatan ini itu macet, dia tidak bisa ditutup seperti itu. Kondisinya terbuka terus begitu kan ininya. Nah, kemudian terjadi juga begitu kan ininya pada tahun 2019-an kira-kira begitu kan ininya itu selain shutternya yang berasal dari instrumen ini, shutternya yang ada di reaktor pun begitu kan itu tidak bisa juga dibuka, sehingga akhirnya kita harus membongkar gitu, membongkar habis begitu kan ininya di N1, sehingga dari sini begitu kan saya tidak mengalami pembangunannya ini, tapi saya pernah bongkar gitu ininya instrumen ini sampai bisa dikatakan habis seperti itu, dan kemudian mengembalikannya ke semula dan juga memperbaiki shutter yang tidak bisa ditutup di sini seperti itu. Nah, kemudian ini adalah penampilan diffractometer kita beberapa jam yang lalu saya ambil begitu kan ininya. Bisa kita lihat di bagian yang ini tadi, bagian yang saya katakan kosong tadi, sekarang di sini berisi penuh begitu kan ininya. Kemudian detektornya pun sudah berubah dari detektor 0 dimensi menjadi detektor 2 dimensi, dan juga di sini ada sesuatu yang menarik. Ini jadi kenangan indahnya Prof. Ana juga begitu, di mana kita bisa membuat sendiri begitu radial kolimator yang pada saat itu pernah saya presentasikan. Radial kolimator kita itu waktu pertama kali membuat begitu saya menggunakan kertas begitu, sehingga itu jadi ternyata di recognize oleh Prof. Ana seperti itu gitu kan ininya. Nah, perbedaan instrumen kita pada saat awal dengan pada saat sekarang ini, yang pertama dari sisi monokromatornya sekarang kita menggunakan focusing ganda begitu ininya, dan kristal yang digunakan. Kemudian yang lainnya lagi adalah kolimator. Di sisi kolimatornya yang kedua tidak kita pakai karena apa? Karena kita menggunakan double focusing seperti itu ininya. Nah, kemudian translator ini pasti diperlukan gitu kan ininya. Tetapi memang jangkauannya kita sampai sekarang masih sekitar 70 plus minus ya, jadi total 140 mm. Kemudian slitnya kita menggunakan narrower pada saat awalnya, tapi sekarang kita menggunakan slit yang fix seperti itu dari 2 sampai 5 mm persegi. Detektornya kita menggunakan 2 dimensi, ukurannya 100 kali 100, kemudian menggunakan sistem delay line seperti itu. Peralatan tambahannya kita ada cryostat 10 sampai 10 Kelvin, kemudian tensile rig sampai 1 kilonewton, dan juga kita punya tensile rig yang unik begitu ininya, di mana tensile rig-nya cukup kecil dan bisa kita attach di meja sampel kita yang cukup kecil. Kemudian perangkat lunaknya gitu kan ininya, pada saat awalnya kita menggunakan yang kopi dari Jairi, tetapi sekarang kita juga mengembangkan sendiri perangkat lunak yang saya kasih nama perkusidahan. Ini adalah hasil karya kita sendiri begitu kan ininya, di mana kita bangun dengan menggunakan review. Kemudian sistem kendalinya waktu itu juga menggunakan pakai Jairi, kemudian kita bisa bangun sendiri begitu kan ininya dengan menggunakan PXI dari National Instrument. Kemudian sistem operasinya kita menggunakan Windows, karena beberapa peralatan yang di sini memerlukan Windows. Sebenarnya kita ingin sistem operasinya juga open source seperti itu, tapi karena pendukungnya masih memerlukan Windows, jadi akhirnya kita masih tetap menggunakan Windows. Ini adalah contoh-contoh aplikasi pengukuran tegangan sisa Dan ini adalah dari civil engineering juga, seperti halnya tadi di ini Profesor Ana begitu kan, ininya kita juga beberapa meninikan dari civil engineering. Ini adalah struktur penahan atau penahan gempa begitu. Kebetulan ini studentnya ini berasal dari Aceh begitu, sehingga penelitian ini sangat bermanfaat untuk mereka, di mana daerah itu sangat sering diguncang oleh gempa. Bagaimana menciptakan suatu struktur yang bisa menahan gempa, syukur-syukur bisa menyerap energi yang ada dari gempa tersebut sampai strukturnya tidak mengalami kegagalan begitu. Dan alhamdulillah ini juga diapresiasi di perguruan tinggi di ITB begitu kan, ini ya, sehingga mendapatkan summa cum laude. Ini adalah contoh yang lain pengukuran residual stress pada turbine blade. Tapi di sini turbine blade-nya memang belum dimachining, jadi ini masih hasil dari casting seperti itu, di mana bisa kita lihat bagian tengahnya, kan, di tengah blade-nya itu dia mostly adalah compressive residual stress seperti itu. Nah, kemudian selain residual stress begitu kan, ininya ada satu fingerprint yang ditinggalkan oleh suatu proses rekayasa, yaitu apa yang kita kenal dengan tekstur seperti itu gitu. Ininya contoh ini adalah hasil rekayasa severe plastic deformation berupa ECAP gitu ya. Ini ada bahan di sini begitu kan, ini tadinya di atas gini bahannya, kemudian didorong begitu kan, ininya. Nah, kemudian di sini dibelokkan begitu. Nah, di tempat sinilah terjadi deformasi yang sangat luar biasa seperti itu. Nah, deformasi ini akan menyebabkan terjadinya tekstur seperti itu gitu. Bisa kita lihat di sini ada tekstur dari bidang 111, 200 dan 220 seperti itu. Dan ini kita dapatkan peroleh dengan menggunakan diffractometer kita tadi. Seperti itu. Apa bedanya yang ini dengan X-ray begitu kan, ininya? Kalau kita peroleh dengan X-ray, katakanlah dengan EBSD begitu, maka EBSD itu akan melihat bagian yang kecil saja gitu, ini ya, dan kemudian dia adalah tekstur di permukaan. Tetapi kalau yang kita lihat dengan menggunakan neutron, ini adalah tekstur dari bulknya seperti itu. Hal lain lagi adalah pada persiapan sampelnya, di mana dengan menggunakan neutron, persiapan sampel atau preparasi sampel itu bisa diminimalisir, atau bahkan begitu kan, ininya seperti kita lihat di sebelumnya sini, ini sampelnya baru keluar dari bengkel begitu bisa langsung diukur dengan menggunakan diffractometer kita seperti itu. Nah, ini adalah contoh penggunaan yang X-ray begitu, ininya. Untuk bentuk yang luar biasa begini sulitnya begitu kan, ininya tentunya kalau di neutron itu akan sulit begitu ininya. Kenapa demikian? Karena di tempat kita itu sampel space-nya juga masih terbatas gitu. Berbeda dengan yang ada di Kowari, di Ansto, di mana sampel space-nya cukup luas, tapi di tempat kita belum bisa seperti itu. Sehingga untuk yang seperti ini gitu kan, ini kita bisa gunakan mobile diffractometer kita seperti itu. Ini adalah contoh residual stress karena pengelasan pada velg SUV. Seperti itu, bisa kita lihat hasilnya di sini begitu kan, ininya, ini ujung-ujung ini adalah awal dan akhirnya lasan begitu, ininya. Nah, kemudian begitu ininya ada 4 daerah yang kita evaluasi begitu, ini ya, ada 1, 2, 3, 4. Dari sini kita lihat begitu kan, ininya hampir di semua tempat begitu, di daerah 4 ini residual stress-nya itu cukup rendah begitu, ininya. ini bisa jadi begitu kan ini ya disebabkan oleh weldernya yang mungkin di 4 ini bagian yang terakhir begitu ini, sehingga sehingga performance dari weldernya itu udah mulai turun begitu ininya. Dan kemudian kita bisa lihat di sini bahwa awal dan akhir lasan itu juga terjadi perbedaan tegangan sisa seperti itu gitu ini ya. Nah, apa gunanya sih di sini begitu kan ininya tegangan sisa di sini? Tegangan sisa di sini itu untuk memastikan bahwa velg yang kita pakai itu cukup safe begitu ininya. Kita lihat di sini tegangan sisanya ternyata apa? Ternyata cukup tinggi dan tensile begitu ininya.
You
Sehingga
have 3 minutes left.
Oke, ya, thank you. Ya, di sini kita lihat tegangan sisanya masih cukup tinggi, sehingga apa yang ini perlu diturunkan untuk menjamin keselamatannya seperti itu. Ini adalah contoh lain untuk sampel yang cukup besar begitu ininya. Ini adalah sampel las-lasan seperti itu, dan kita ukur dengan menggunakan mobile diffractometer kita. Kita lihat di sini bahwa tegangan sisa pas di well 2 di sini itu cukup tinggi dan tensile. Di sini ada mostly adalah kompresi. Ini mungkin disebabkan karena permukaan ini itu dilakukan penggosokan seperti itu gitu ininya, yang dilakukan oleh customernya. Kita sebenarnya nggak pengen seperti itu gitu kan ininya. Nah, kemudian ini adalah peralatan yang lain laboratory XRD seperti itu yang kita konstruksi menjadi pengukur tegangan sisa. Semoga yang ini di masa BRIN ini tidak dihancurkan lagi begitu ininya, karena ini tadinya juga abandoned gitu ininya, kemudian kita coba perbaiki dan alhamdulillah sudah bagus begitu ininya, dan sudah menghasilkan sudah coba kita bandingkan dengan komparasi begitu menggunakan 2 metode yang berbeda. Kalau yang laboratory begini biasanya digunakan sin square psi method begitu ini, sementara kalau yang mobile tadi kita gunakan cos alpha, dan ternyata keduanya memiliki kesamaan hasil antara sin square psi dan cos alpha. Kemudian sebagai penutup begitu kan ininya, yang pertama teknik diffraksi neutron atau sinar X dapat digunakan untuk mengukur tegangan sisa secara tidak merusak. Kemudian diffraksi sinar X digunakan untuk mengukur tegangan sisa permukaan, sementara berkas neutron digunakan untuk mengukur tegangan sisa internal. Kita memiliki fasilitas pengukur tegangan sisa dengan metode diffraksi yang lengkap dan canggih. Marilah kita manfaatkan sumber daya ini. Kemudian berikutnya lagi bagaimana menggunakannya, beam time application-nya. Saya belum tahu di masa BRIN ini begitu ininya bagaimana, karena sebelumnya biasanya gitu kan ininya beam time application bisa kita kirimkan lewat email atau langsung berkomunikasi dengan instrumen scientist. Sementara di BRIN ini saya lihat belum ada instrumen scientist, jadi kita masih belum tahu. Barangkali itu apa yang bisa kami sampaikan. Terima kasih dan mohon feedback dari Bapak Ibu sekalian.
Okay, thank you very much, Pak Rifai, for your very interesting presentations. Mr. Rifai has introduced you technique to measure residual stress, their instrumentations, and also what instrument available in our laboratory. So it's opportunity for all of you, especially coming from mechanical engineering, civil engineering, material engineering, to have a discussion with Mr. Rifai. Thank you again, Mr. Rifai. So before next presentations, I will remind you, all the audience, if you have any questions, please write down or type in chat box, and please mention also to whom your questions is addressed to. And you can also raise your hand during the discussion sessions. So let me show the short CV of next, the last but not least presenters. So I think, yes, this is the personal information of Mr. Fahru Rozi. he has a bachelor's in electrical engineering at Udayana University, Bali, and also has got master's degree in nuclear energy productions for industrial applications from France. I'm sorry, I can speak French, so perhaps my pronunciation is not correct. IMT Atlantic Pays de la Loire, no, France. Is it correct, Mr. Oji?
Yeah, a little.
Okay. And also, Mr. Oji has many training and workshops attended. This is several of them, and all of them held abroad in Germany, PSI Switzerland, and HZB Germany, and Thailand, and also in France. And also he has published more, I think, international publications, especially in neutron radiography. So I think it's time to hear and to give time and screen to Mr. Oji. Please, Mr. Oji.
Okay. Can you see my presentation?
Yes, I can see.
Okay. Thank you very much. Again, I'm Ozzy. But first of all, I would like to say thank you for Research Center and Technology for Radiation Detections and Nuclear Analysis, and for Dr. Abu Khalid Rifai for the time that you give to me to present this in this symposium. Okay, today I'm going to talk about the art of the neutron imaging technique for research and industrial applications. And then, yeah, this neutron imaging, some of us call it BRIN. This is from the Indonesian abbreviation, actually, but in English it should be BRIN, Neutron Radiography of Indonesia. So, okay, this one, I can try to deliver the information to you, starting from the neutron imaging, of course, yeah, but only a brief information about the neutron imaging in BRIN, yeah. And then going down to the research and industrial application, of course. Okay, yeah, we are in here in the Kawasan Nuclear Surveillance, and building number 30 is a nuclear research reactor in Indonesia. Actually, we have 3 nuclear research reactor in Indonesia, and focusing only, I think, in Java Island. Okay, and then this is the youngest one, but still the biggest one operated until now. It can be operated until 30 megawatts, but due to the efficiency, yeah, it would be working for about 15 megawatts. Okay, beside this building, we have building number 40. And this building number 40, we usually do for the data analysis and for the image reconstructions. Yeah, I forgot to tell you that for the neutron radiography is inside the nuclear reactor building. So it means in the building number 30. Okay, now we are starting to discuss about the neutron imaging. I will tell you guys about what is the neutron imaging in the brief knowledge. So this is the fundamental of the nuclear imaging, yeah, the neutron imaging. Okay, so we are normally in our group in the neutron imaging, in the neutron radiographer. We call ourselves is for photographer, but the difference is we are supported by a very huge infrastructure. It's called a reactor, right? So in here we have a guide tube in here. Yeah, so maybe you know that neutrons, yeah, nuclear reactor produce neutrons, and then we use this neutron, yeah, as a source to detect this, like to investigate some sample. Yeah, it can be a research sample in here. Just in here, but this neutron should be guided from the nuclear pool and nuclear reactor to this neutron radiography chamber. So I put this one. This is the sample, and then this is put on the table. the sample table. That this sample table can be rotated until the 360 degree. And then I have also the detector in here, lithium detector, with the thickness of about 100 to 15 micron detector. And then, yeah, I forgot to tell you guys, this one is inside the dark box. So this is this inside the dark box. They have it has a TiO2. It's a mirror with maybe reflectivity is about up to 95%. And then we have an under camera with 5 micron resolution. And before going down to the computer to record everything image, yeah, we get from the this activity. Okay, for the sample table, we have the maximum weight of the sample is 25 kilogram, and the maximum the dimensions for the sample is about 30 to 30 centimeters square cube. Okay, so this one is our sample, and then this is the resolution. So it's about 200 microns resolution. Yeah, it is higher than the under camera, of course. Okay, and if you are well known about the neutron imaging, there's another resolution. It's called L over D. It's in here we have only 87. Yes, less, but it's enough if you want to investigating some industrial sample. Okay, we have in here we have field methods and camera methods, but from both of them we can break down to 3 advanced techniques. For first is radiography. For the radiography, we can do it with field methods or the camera method. And for the dynamic radiography and tomography is absolutely using this camera method. Yeah, we have an under, right? So how does it work? So this one, if we are a neutron in here, and then this neutron is guided, and then hit the sample, of course, and then there will be like a neutron interactions with matter. And then it can be scatter, absorb, or transmit. It means not interactions, and then detected by detector before this guy to like changing the neutron to be light. Yeah, to be light is in the green band, and then before it take it to the this camera and record it to the computer. So yeah, this is the basic concept of the neutron imaging. For the if you are working with the dynamic radiography, you don't need to deal with the sample table, because you don't need to rotate it, right? For the dynamic radiography and for tomography, we need to rotate it this sample into 360 and image recorded every 0.5 degree. At least we have a 720 data image before we reconstructed using the octopus software or MUHREC. Yeah, MUHREC is like a free software. You can get it in the internet, and then also doing the data analysis by using a Fiji Studio or the ImageJ. Okay, so what is the good thing that we can do with NI neutron imaging? I mentioned about we have 3 methods, right? So the first is dynamic neutron imaging. Is you can do it for the oscillating heat pipe. We did it with Indonesia University, and this is for heat transfer, in the electronic system. Okay, we did it again, and then also for the neutron radiography. Okay, we can do it for porosity measurement inside material or water transfer inside a rice plane, but it's still not completed yet for the water transport, because I need to change the system from the transmit to the scattering, I think, because we don't use in here, we are not using a scattering radiography, so still transmit a radiography. That's why it's very crucial if we can change it. And then maybe it's much more good thing to deal with the rice plane, transport, the water transport inside. Okay, so in here for the neutron tomography is the most famous one, and then I am still working with the oil content inside the rock sample in here, and And then we can do it this neutron imaging for the porosity inside measurement, quantifying or qualify the porosity inside material and reveal the ancient technology in the archaeological sample. Of course, before I'm going down to research and industrial application, I'm sorry, I cannot tell everything about this sample, this interesting sample. So I just mentioned, maybe I can give you one or two example only in this symposium. Okay, for the research application. Okay, it is we can do like a rush measurement on the part sample. It is lead by the Dr. Eni Sugiyarti from LIPI. Right now, it's another research institution before, but right now we have already in the same boat. In BRIN, it's called BRIN. BRIN also is from the Indonesian's abbreviations. Whatever. So this is the system that you can imagine that there's a box in here. So in here in the gray box, this box, and then you can steam this asset, and then you can imagine that this is a pipe. So this is and then there will be like a two-part pipe in here. One is coated with the rust coating paint, and then second one is just let it by default, so without anti-rust paint. And then after that, you steam it with very high acid for it's about 48 to 72 hours, and then you just quantify the rust again with tomography. This is possible. We can do this experiment. And then next is collaborated with the BT Prayoga, is another PhD student from the Gajah Mada University, and it has been published in the IUP Science. This is the defect volume. The idea is to measure the defect volume of the internal poles of the as casting, femoral knee centrifuge investment casting. So they have 3 sample in here. With different velocity. It's 45 RPM, 55 RPM, and 65 RPM. As you can see in here. So in the top of this, in the laptop, this is the result from the radiography image. Taken by the field methods. And then this one is by the tomography. After we took the data and reconstructed, and then we can measure the porosity and also quantify, qualify, something like that. And then the result is we can from the sample A and C has 1.78% of the total porosity, and B is 2.78% of from the total porosity. So we know that maybe I can say that 45 RPM and 65 RPM is much better because less porosity inside the sample. Okay, so for the industrial applications, until I think starting from the 2019 until now, we are focusing on the EOR and oil refinery. EOR is the enhanced oil recovery. And then this technique is one of an advanced technique that I will show you in the next slide. So before I'm going down to the neutron imaging applications in the industrial application, we should know the life cycle of these oil mines. So starting from the explorations, of course, because you need to make sure that in this area you have an oil, right? So they just exploration, take samples from that. It can be normally it can be sandstone or the limestone sample. So they take it and then take to the laboratory and then measure the porosity, the total porosity. If it is more than 20%, it say that it's have a big opportunity to get an oil. So this is starting point for the life cycle of the oil. and then they develop. If they just say, okay, say it is an oil inside in the ground, so they just develop this field and early production until a full production. Yeah, they take everything oil as much as possible, and then before it reclamations. Okay, but again, do they really reclamation? This is the question, because until now, there's there's no such technology that can extract an oil in the mine field 100%. It's only maximum is only the 40 to 60% is the maximum that you can get with this for today technology. So this is the introductions about the EOR technology to tap more. Hopefully they can extract 40 to 50% extract more oil. Yeah, because you know that if they don't do reclamation, they should maybe try to find out the new oil refinery. But right now it's much more harder and harder. So they are going back to the old oil refinery. So this is technique is very important for them, yeah, for the oil industry and this company to extract more oil. The DER is using, maybe you know that they use, sometimes they use steam, pressure, high pressure, or they are using like chemistry, chemical, something like that, chemical solution, something like that. So here, now we are going to the why neutron imaging is good for this kind of issue, to address this issue. Okay, first is the neutron interactions with matter. So you know that the neutron is very good, very good contrast to a light element such as hydrogen, carbon, and something like that. And this neutron imaging is a complementary technique for the X-ray imaging, of course. But sometimes we can there's a sample that only neutron can deal. Okay, and then this is a very powerful tool to investigate sample non-destructively, of course. Yeah, and then this is a very interesting thing that in 2019, Pertamina is another industry. Yeah, this is it's a government industrial that really focusing on the oil extractions. Yeah. So this is Pertamina was looking for a new solution to extract more oil from old oil refinery. Okay, so this is a good thing for maybe we can address this by using a neutron radiography or neutron imaging. Okay, now what we did since 2019, also in the end of 2019, we collaborated with the university, Trisakti University, Master of Petroleum and Earth Department to take to provide us a very some good sample. Yeah, so they gave us a sample from this sandstone. Yeah, I did a mistake from this. For this limestone, for the limestone, I got it from the Lemigas, but this sandstone, I got it from the Trisakti University. Yeah, Lemigas is another research center for dedicated to oil and petroleum, oil and gas research. Okay, this is the primary investigations with the limestone. This one is the limestone sample. And then I did it with X-ray and then neutron tomography, and then you can see that when I just
sorry, Mr. Oji, you have 3 minutes.
Okay.
Thank you.
Okay. When we did it with tomography and then reconstructed, and then this is I can slice it virtually. So I can get it this kind of information. So this is when I just cut it from the 1 centimeter from the top, and then 2 centimeter from the top, and then 3 centimeter from the top, and then I got this kind of slice, and you can see that the result is different between the X-ray and the neutron imaging, right? If I just magnify this one is to make it clear, so this you can see that's different information you can gain from the X-ray or the neutrons radiography. Okay, so you can see this pore channel. Actually, for the pore, for the case of the limestone, for the limestone, it's completely for X-ray. It's much better to see the pore of the limestone sample. But for the sandstone sample, you can deal it with neutron also. In here, you can see that there's a link pore. So it is a link from the top to the bottom. Yeah, it's a channel pore, and also a furgular pore and crystalline pore. So this is the 3D image of this sample. In this green and blue, this is a trapped pore that it didn't link one to each other. And this one, when I just deal with the sandstone, sorry. Yeah, okay, this is when I just deal with neutron. This is only pure with, I take it with a neutron, but they did it measurement before with gas, because they can normally they use gas to measure how much gas for the porosity inside the total porosity. But neutron also did the same. Yeah, and then I can see that you can see that it's not a lot of difference between gas and the neutron's porosity, and so you can see the pattern of the pore and the link of the porosity. Okay, that's it. Finished already. Now you can deal with for the EOR technique. Maybe I can show you the video. Okay, see the brown one is the oil, and this one is the total of the volume of the rock. So I can manipulate, like I can just slice it down, up and down, and then I can also measure the quantify of this volume of the oil inside the rock sample. Okay, this is still ongoing. If you are interested with this kind of research, you can contact us in Neutron Radiography group. I think this one is the last slide that I can share to you guys. And then thank you very much for your attention. If you have any question, you can do not hesitate to ask me. Thank you.
Okay, thank you very much, Mr. Oji, for your very nice presentation.
Yeah, sorry, I think I talked it quite
no, it's
fast.
already in time, so it's appreciate to you.
Yeah. I hope I'm not talking too fast.
No, it's okay. So I think Mr. Oji has gave us introductions of the technique of neutron radiography, and also gave information about what have been done with our instrument. Especially at present, we have started to deal with the problem faced by industry or applicative problems. So in the agenda, it's written that the symposium of our webinar will be finished at 3:30, but perhaps we still have a 30-minute discussion. So I ask permissions to Dr. Abu and all of you to still patience, to still with us, to have discussions, ask some questions to the presenters today. So please, you can raise your hand, but while waiting for the direct questions, I would like to read some questions coming from Dr. Abu, addressed to Prof. Anna. Yes, the first question is, you mentioned about 3D MD laser metal deposition printer for neutron measurements as the first in the world. Could you explain more about that systems? And the second question is, what's the maximum of sample size can be characterized for neutron's residual stress in your facility?
Okay, so
Please,
I start
Prof.
with the second question. So we have a capacity of putting 1 ton on our sample stage. So we can do very large component and very small components. So our positioning stage moves plus minus 250 millimeter, and we can go half a meter below the specimen. So, you know, we can have the specimen once elongated even up to 2 meters in one direction. So we look at the specimens as big as 2 meters. In the past, I think we can. The biggest samples that we measure was that pipe that I showcased there, is a 600 kilograms pipe, and to put it in the position, I also have to build a stage to put it at the angle that was 200 kilograms to do it. So so far the biggest component I ever put it on Kovari was 880 kilograms. But we think that we can put it up to a ton. So if anybody have samples of this size, please let us know. Regarding the first part of the question, so in situ treatment and in situ printing and welding, we done it in the past. I mean, we actually, when I was at ISIS, we did welding. I also have some successes in welding, but this is powder direct laser metal deposition. So this is why it's a first of its kind, because people deal with wires in before, but dealing with powder in the neutron diffraction source, you know for yourself, is very difficult. And so we can, our system is very simple. You know, we have automatic stage that moves in terms of the height and in terms of the longitudinal direction. So we're measuring as we depositing in a steady state condition. So at the moment we have a capability to build walls, of multiple thicknesses. Our laser is optimized from 1 millimeter to 3 millimeter weld pool. And but in the future we would like to do round components and maybe corner sections, but at this stage, as this is our first trial, and I have a postdoc working on it, and we wanted to optimize it and put it for the dingo, so our imaging beamline next time. I think we are only able to build small samples, so I would say 200 millimeter in length walls of probably 200 millimeter height. Yeah, I hope that answered the questions.
Okay, Dr. Abu, any
Yes.
comments or questions?
Thank you for your explanation, Prof. Anna.
Okay, thank so let's read again the questions coming from audience. The third one's coming from Abu. I think your questions to Prof. Ilman has been answered. Is that correct? In the chat room.
Yes, I think yes. Prof.
Ilman,
Ilman
still have discussions with Miss Prof. Ilman or not?
No, I think it's enough. But yes, Prof. Ilman explained that it's a good idea to do that in the future.
Okay.
Yes.
Thank you.
So we open for the collaboration, Prof. Ilman.
Yes, for sure. Hope we can realize this collaboration there. And also to Prof. Anna, probably will have collaboration with us in the future.
One exciting thing I wanted to say, I'm building a center for solid state manufacturing, actually. First friction stir printer. So which we should have it available very, very soon, probably mid next year or end next year. And yeah, I would be very keen if there is any industry or academic partners interested in machines that can do processing, welding, and 3D printing in friction stir processing. I would be very keen. Also, large-scale vibrations, very interested. I mean, industry, this is a very cheap technique to release residual stresses in large-scale component. We have lots of interest and collaboration in that space. Too.
Thanks.
Okay, thank you. From this symposiums, there will be many things we can do together in the future. So next questions coming from Miss Sri Vidya Swastika. So she has 2 questions. The first one addressed to Prof. Ilman. Her question is: you are using Neutron method, right? Could your sample using cos alpha method too? Thank you.
Yes, actually, I have answered the question. Actually, we use neutron diffraction technique to measure residual stress, but I think the right person to explain about the detail of this technique could be Mr. Rifai to explain it. Thanks.
Okay. Okay, Ms. Vidya, any comment or any further questions related to the first one? Oh, I think she couldn't hear us. So next question from Ms. Trividya is addressed to Mr. Rifai. Could you explain shortly between cos alpha versus sin square psi method? Thank you.
Okay. The principal difference of sin alpha and sin square psi and cos alpha is a detector. For sin square psi, we can use a point detector, zero dimension detector. But for cos alpha, we have to use a 2-dimension detector. That's maybe most important of that 2 methods.
Thank you.
What Anna? Do you have any comment, Anna? Your microphone.
I think in principle you can use both, yeah. But they are the surface technique rather than subsurface. So for subsurface you need to use neutrons, but on the surface you can use both. The techniques will be probably suitable. The cosinus technique doesn't require that much surface preparation, you know, as much as the conventional sine square. But I think both are very well, and they portable. So that's the biggest advantages. So if you wanted to answer the problem, I always recommend it to my clients and students, use more than one technique, because every technique have pros and cons and advantages and disadvantages.
Okay, thank you. Any comment from Ms. Trividya Swastika?
No. Yes, thank you very much.
Okay, satisfied with the
satisfied. Thank you,
thank you.
speakers.
So let's continue the next questions coming from Pak Kristejo. I think it's to Prof. Anna. Dear Prof. Anna, how did you organize your Neutron BIM facilities to maximize utilizations of the facilities? And second, could you share some of your success story, collaborate with broad private company users? Please, Prof. Anna.
Okay, so we operate Neutron facilities industrial liaison office since 2014. Okay, the biggest challenge I would say was to convince the industry to work. Can I just have a moment? My husband is calling me. I just
okay.
1 second,
okay,
maybe, and I come back to that.
Okay. Okay, and if you have any questions, please write down in chat box or raise your hand.
I'm sorry, it's a bit late here and I need to go in a couple of minutes, but I wanted to answer that question.
Okay,
I really appreciate that question. So I think the point is that there are 2 challenges for us. First, industry doesn't know that we exist and they're not particularly looking for them. They like to work with the techniques they're familiar with. Yeah. So as you know, I'm an engineer. Yeah, so majority of my colleagues are physicists and chemists and crystallographers. Yeah, so when you put the engineers in the beamline, they will look for engineering solution. I would strongly recommend that, and it takes you have to show by example that interaction with industry is possible. And I find myself that even for our industry, we are expensive. Yeah. So what I specialize with is actually writing a grants to help industry to pay us. Yeah, so we can have a collaborative grants that we can have PhD students and work together on providing a solution. Because rather than have one client for 2 days, I would prefer to have a client for 3 years and working on real solutions. Repetitive clients is better than any advertising. Yeah, so I think it's so important that you build stronger partnerships and you grow with your company. So I think I am been very lucky that I've been in this business for many years, and I work with companies in Europe and in Australia, and it's about building relationships. Sometimes I talk to my clients and we don't have projects for 2 years, but then I always tell them, okay, I will be patient. I'm learning during the time they are also growing. I am experimenting with my PhD students, so I am ready when they have problems, because industry is not paying for experiments. Industry is paying for solution. So this is so important, that this building interaction and creating the next generation of scientists that know, young students that knows how to use our large-scale facility is a key to our success in the future. So more we have these ambassadors for our nuclear facilities in industry, the better we're doing. So it's so important for us in Australia, and I'm sure it's important for you in Indonesia, that growing the community, meetings like that when the academics and industry can interact, that is a key to success. Thank you for that question. That's excellent.
Okay, thank you for your answers, Prof. Anna. Any comment or any further questions from Pak Chris? I couldn't hear your voice. I think it's enough. Okay, enough. So do you still have time, Prof. Anna, or you should leave now?
5 minutes, and after that I'm going. I need to feed my children.
So any more questions to Prof. Anna before she leaves us? Please, Pak Rifai.
Yeah, maybe you can share your experience with social media, Prof. Anna.
Okay, I think it's so important that we have to be where industry is. Yeah, so I am mother of 2 children, and I don't have that much time to go to many conferences these days. So I find social media like LinkedIn and Twitter very useful because it allows me to promote my colleagues at our facility, and promotes my students and promotes my science, and also comment and see what industry is currently promoting. Yeah, so you have to be proactive, and like it takes time to build audience, but sincerely I would suggest that it's a must these days, because one of the things that I also do for my industry is promoting my industry over social media. I promote the interactions, and sometimes, they spend more on advertising than they spend on research. So if you can do both, it really pays off. For that reason, I will really, really recommend it, that to have a scientific profile, to put it up there, all those beautiful pictures that we see today, like especially in imaging and residual stress maps and texture, it doesn't have to always be a paper. You just have to visualize to your industry clients what you are doing and how that can be relatable to their problems. That is something that I'm still learning, the art of communicating complex experiments and complex scientific issue in a simple way. Einstein said that if you can explain it to your grandmother, you really understand the subject. So think that way and try to explain in a few characters, few lines, your complex instrumentation and how that provides a solution. I make lots of clients online, Sometimes it takes time, like it doesn't always happen, but you just have to keep them informed, like be systematic. And I think it's a very good platform for events. So if you organizing events, put it up there that you will be talking about that particular problem, or workshops. Is also the next generation. So the young scientists are using social media, Instagram, Twitter, LinkedIn. The opportunity to reach them is a key, because they are the ones that are still absorbing. They're not scared of novel technology. And I think for me, that is particularly of interest, because I'm on a mission to create the next generation of people who know how to use large-scale facility. It doesn't matter where they are, as long as if they know what Neutron brings to the equation to provide solution for industry, we're winning. I mean, the highlights that you presented today are excellent. Yeah, so I hope more people besides this meeting could see it. So I think visibility matters, and I encourage you to go on LinkedIn.
How about the content in YouTube?
I think YouTube is also very good. It requires maybe, I don't know if you're editoring this after all. I would strongly recommend to make it shorter as possible. So just the key messages that you wanted to people span is 15 minutes. So even if you have we have a nearly 2 hours meeting, I will think of it like, oh, you wanted to make this meeting as a 2-hour, excellent, but also make a short messages like, okay, this is a 15-minute highlight, because like when you really look at it, I treat social media as a statistic package. Yeah. And if you see what is actually being seen on the YouTube in a high mode is, 3 to 5 minute videos are winning over so and I actually think, you have meetings like this and you can package it into large package for people who wanted to deep in and absorb everything, but you also can have this short promotion highlights of the presentations that can really highlight the important things, how we provide the solution. I will strongly recommend it. We as ANSTO, we have a promotion campaigns, and we're seeing that shorter we go, the better we go. Like the most visible we are. Yeah, because people who wanted to deep in, they will search for a long presentation. You have to have them both online, but the short presentation, 1-3 minutes, are actually much more because teacher can use them in the classroom at universities, when they short. So it offers you a bigger audience, people can use them in the presentation. So for example, like I have a client who have engine blocks. I did some scanning with his instrumentation, and he uses that part of the video in the presentation to his clients, so this short little messages going a long way.
That's right. That in the university, the student need only answer of the question. Eh?
That's true.
Okay, it's enough, Ms. Pak Rifai.
But one another. Now you have many followers in your LinkedIn or Twitter. Do you hire some special staff or something like that?
In science, do you think I have people?
Okay.
No, I am doing all. I wish. Maybe one day. Okay. One day.
I will send my CV.
I mean, maybe, if that is something that interests you, how to promote it, I would be happy to offer training, how to reach, because, I am not a tribalizer. I'm actually a promoter, like I'm focusing on promoting my facility. I'm not trying to be what they call it, influencer. No, I am not an influencer, I'm a promoter. And that's a slightly different set of skill. If that is something that you want, we can discuss it in the future for a short workshop to help your young scientists to, try to explore that opportunity.
Okay.
More people, more scientists on the LinkedIn is better for me.
Yeah. I think it's very good if you are using this social media, but another problem is sometimes scientists cannot deliver their message to industry, right? This is very different because scientists sometimes talk with scientific languages, and then it is very hard sometimes to, for industrial or the community to take what the purpose or what's the meaning, what the message that we try to deliver, right?
Yeah, that's true. That's why, if I think, we have to, rather than explaining our things in a sophisticated manner, simple is always better. Don't try to overdo it, because, like if you can simplify, that's gold. If you can share your complex equations and complex instrumentation in a very simple way, everybody will buy it, even the industry and academia, because everybody can make things complicated. Not everybody can make things simpler.
Yeah, true, right.
I really have to run. I am so sorry.
No thank you very much.
It is so nice to meet you all.
Nice to meet you. I think you
have a lovely weekend, everyone. And
please
bye.
wait for our next invitations to do workshop in
social media.
Oh, now you have that. I can't say no now.
Okay, thank you very much, Prof. Anna. Bye. Oke, we still have bahasa Indonesia aja atau gimana nih? Bahasa Inggris cuma ada Ana aja kan ya di sini ya kayaknya.
Kalau saya sih tadi ininya ada dari Malaysia, tapi masih stay nggak dia? Ada dari Malaysia tadi saya ini.
So we have 5 minutes left. Please, if you have some questions to Pak Rifai, Pak Ozi, or Prof. Ilman, please raise your hand or you can type in chat box. So I have questions to Prof. Ilman, actually, non-technical questions, but I think what percentage of data coming from our instrument going to publish? First questions, and second, we as the instruments scientists believe that the additions of Neutron's data could increase the probability of acceptance of the paper to the journals. What do you think about that? Thank you, Prof. Ilman.
Sorry, what is the first question?
The first one is what is the percentage of data coming from our instrument that going to publish until present? Thank you.
Okay, thanks. Actually, we did we usually do some work like microstructure and hardness, tensile test, mechanical and fatigue and other mechanical properties, and then combined with characterization or measurement using residual stress. I think from my decision around 70% of the total work in one paper come from my university, and then the remaining 30% from the neutron diffraction work. But I think yes, as you mentioned that with using using residual stress analysis, it will improve the quality of the paper, I think. It's higher than that without residual stress data.
Okay, thank you very
Hopefully
much.
you understand.
Yeah, thank you, very clear.
Yes.
So any more questions? So in the chat box there are not questions, but maybe some audience need presentation slides from presenters. So if you don't mind, you could send your presentations through the chat box so the audience can download it to Mr. Rifai, Mr. Oji, or Prof. Ilman, if you don't mind to share your presentation slides.
Yeah,
okay, thank you. And maybe the panitia will contact Anna to ask her to send also a presentation slide. But maybe we will need time to to communicate with Anna. So I think if there are no more questions, let us. Sorry, I'm so sorry for my part during moderate these presentations and discussion sessions, and I thank again to all of your presentations from Ilman, Pak Rifai, Oji, and from Anna, and also thank you very much for attentions from all audience. So I'll give back to Mas Dian. Thank you very much.
Thank you, Mr. Iwan, for your guidance in this webinar. So, can I speak in Indonesian or should I say in English? Okay, I will talk in English. Okay, dear all participants, today's webinar is now over. But before we close this meeting, let's take our picture together. Please, to all participants, open your camera. Silahkan dibuka kameranya semua. Kita mulai dari slide pertama. Oke. Bentar ya, masih slide pertama. Oke. Malah ngehang ini komputernya. Oke. Tahan ya, tahan ya. Tahan ya. Oke ya, sekarang slide kedua. Nah, sekarang slide ketiga dan terakhir. Ya, demikian sudah selesai, bisa ditutup kembali kameranya. Finally, we want to thank you for your participation in today's webinar, especially for all speakers and our moderator today. Thank you, Mrs. Anna Paradovska, Mr. Muhammad Nurilman, Mr. Rifai Muslih, and Mr. Fahru Raji Akbar. And also Mr. Iwan Sumirat for your guidance in this webinar. Thank you, Mr. Abu Khalid Rifai, for organizing this webinar. See you at the next episode of the Voice of Research series. We are sorry for any inconvenience and mistake during today's webinar. Once again, thank you and see you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima
kasih, Mas Aman.
Thank you all of speaker, Mr. Abu. Oke.
Terima kasih semuanya, sama-sama.
Terima kasih semuanya.
Ya, makasih semua itu.
Mas Dian, makasih Mas Dian.
Yuk, sama-sama Pak Abu.
Thank you, Pak Rifai. If you have some webinar, can invite me.
Yeah. Makasih Pak Nur.
Oke, Pak Abu.
Baik, terima kasih. Pamit semuanya. Assalamualaikum.
Iya, waalaikumsalam warahmatullahi wabarakatuh. Kenapa?